Hello geometry students. This is your lesson for section 7-1, Ratio and Proportion. Missy McCarthy, Okemos High School math instructor. The objective in this particular lesson is to write and simplify ratios, which you've seen before, and to use proportions to solve problems, another thing that you've seen before. So let's get started. First, a review of what a ratio is. A ratio is a comparison of two numbers by division. A ratio can be written in several different ways. One way to write a ratio would be to write A to B. Another way you could write a ratio would be A dot dot B. But to have it be the true comparison by division, you can write A divided by B, where B can't be 0. So if we were to look at the ratio of circles to stars, the ratio of circles to stars from this particular figure, we would count the number of circles, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 circles. And then count the number of stars, 1, 2, 3, 4, 5, 6. And we could say that the ratio of stars to circles to stars is 9 to 6. Or we technically should write it in its simplest form. And 3 goes into both of these numbers, so we should say the ratio of circles to stars is 3 to 2. For every 3 circles, there's 2 stars. Now, slope, something we've done with lines, is a ratio. It's a comparison of the rise of a line to the run of a line. So we can write the ratio expressing the slope of line L that we're given here. So this point here is -1, 3, and this point here is 2, -2. So if we were going to find the slope, the rise and the run, we could figure out what that is using that formula, or we can use the slope formula. The slope of L would be the change in y, so -2 minus 3, over the change in x, 2 minus -1. We would end up with -5 over 3, and we have just written the slope of line L as a ratio. Now, a ratio can involve more than just 2 numbers. For this rectangle that we have here, the ratio between the side lengths would be 3 to 7 to 3 to 7. So that's one way we can compare several numbers. Okay? If we were going to write an equation based on these ratios, we could do that by just multiplying by a number. So we have the ratio of side lengths of a triangle is 4 to 5 to 7, and its perimeter is 96. What's the ratio of the shortest side? So like we did in that other example, we reduced, but we don't know if it's 8, 14, and 10, or if it is 12, 21, and 15. We just know that the ratios would reduce to 4 to 7 and into 5. So what we would do is we would take our triangle, we would say, okay, let's this side be 7x, because it's some multiple of 7. Let this side be 4x, and let this side be 5x, because all of those variations would have that same side length ratio. So if they tell us that the perimeter is 96, then we would write, that means that 4x plus 5x plus 7x is equal to 96. If we add these together, we get 16x is equal to 96. And then how many times does 16 go into 96? I'm thinking it's 7 times. I'm going to check it over here on the side. 7 times 6, that would give me a 6. Carry the 3. 7, nope, it wouldn't be 16. Let's try 6 times. 6 times 6, oh, 7 times 6 is 42 anyway. Let's try 6. 6 times 6 is 36. 6 carry the 3. 6 times 1 is 6. Plus 3 is 9. So it's 6. So that means x is 6. So then it said, what is the shortest side length Well, the shortest side length, if the perimeter is going to be 96, we would plug that back in, and we would say the shortest side length is 4 times 6, so it is 24 is our shortest side length. Okay. All right, let's move along here. Now, a proportion is very similar to a ratio, but it is the statement that two ratios are equal. So if I have one ratio A to B, and it's equal to another ratio C to D, then those two ratios form a proportion. Now what this cross product property here is saying is that anytime you have a proportion, one ratio equal to another, if you cross multiply, so A times D, they show that here with the crossing, A times D and C times B, those cross products will be equal. So in a proportion, the cross products are equal. Oh, let's just take a look really quickly at two that we know are equal. If we were to take the fraction 3/4 and say we know that that is equal to 6/8, and we find the cross product, I tend to circle mine as opposed to cross them out. That means that 3 times 8 is going to be equal to 6 times 4, and 24 equals 24. So in every single proportion, which is an equation stating the two ratios are equal, the cross products will always be equal as well. So we can solve this proportion for a variable, and we're going to make sure that we check our answers. So when we solve this proportion, I am going to cross multiply. See if I can get a highlighter here. And I am going to cross multiply there and cross multiply there because the cross products have to be equal. So when I cross multiply for one of the cross products, I think I still have the highlighter. There we go. We end up with z minus 4 times z minus 4, and for the other cross product we end up with 5 times 20. So when I distribute this, I end up with z squared minus 4z minus 4z plus 16 equals 100, and that gives me z squared minus 8z plus 16 equals 100. Now if I'm going to solve this, I've got to get that 100 to the other side and try factoring. So if I subtract 100 on both sides, that gives me z squared minus 8z minus 84 equals equals 0 now. I'm sorry about that. And then can we think of things that we multiply to get 84, but that would add to give us negative 8. So I'm thinking like 12 and I don't know what 12 times 7 is. That wouldn't be a difference of 8 anyway. So let's just take our 84, because I can't think of what those would be, and see what it's divisible by. Is it divisible by 16? Let's see. 84 divided by 16. Nope. Divided by 12. 12 and 7 wouldn't work. Divided by 6. 6 and 14. There we go. So it would be minus 14 and plus 6. So that means we could either say z is equal to 14 or z is equal to negative 6. Now we want to make sure that we check. I'm going to check up here. If we plug 14 in, we get 14 minus 4 over 5 equals 20 over 14 minus 4. 14 minus 4. So that gives us 14 minus 4 is 10 over 5 equals 20. That would be 20 over 10, and that one does work. Okay, now I'm going to check the negative 6. Negative 6 minus 4 over 5 equals 20 over negative 6 minus 4. That gives us negative 10 over 5 equals 20 over negative 10, and that one works as well. So we have two solutions to this proportion. Okay, now let's take a look at this one. It says, given that 18C is equal to 24D, find the ratio of C to D in simplest form. So here we're working backwards. The cross multiplying has already been done, and we need to know what C to D is equal to in its simplest form. So if I start with the original 18C equals 24D, I'm going to take both sides and divide it by CD. If I do that, these C's will cancel. Actually, I'm not going to do that. That would give me the answer eventually, but I think I'm just going to divide both sides by D because I want a C to D. So this gives me 18 times C over D is equal to 24. Now I'm going to divide both sides by 18. And then that gives me these cancels. C over D is equal to 24 over 18. So now as long as we reduce that fraction, we can figure out what our ratio of C to D is. I'm looking at this and I'm thinking 6 goes into both of those. 6 goes into there 4 times and 3 times. So that means the ratio of C to D is 4 to 3 because they said in simplest form. Okay, let's take a look at applying this to some sort of a situational problem. Marta is making a scale drawing of her bedroom. Her rectangular room is 12.5 feet and wide and 15 inches long. So the actual room would be, I'm going to do 15 feet long and 12.5 feet wide. On the scale drawing, the width of her room is 5 inches. So in the smaller version, the width of her room, I had the width as 12.5, so the width is 5 inches. We need to try to figure out what the length of her room is going to be. So I'm going to call that L. So because the proportions of the length to width have to remain the same if it's going to be a nice scale model, we can do proportions of length to width for the two figures. So we could say 12.5 is to 15 the same way that 5 is to L. Then we could cross multiply. We would get 12.5 L is equal to 75. I believe 15 times 5 is 75. And then we can divide both sides by 12.5. And then 75 divided by 12.5 is 6. So the length of the room on the drawing should be 6 inches. And again, we just set the two ratios equal to each other to form and solve a proportion.